space shuttle launch.
What is this?
They saw 4 large machines work together precisely to send
Mission.
astronauts, satellites, observatories, and space station segments into orbit. The 4 elements, when combined ahead of launch, were called a shuttle stack.
What is this?
This is the space shuttle, inside which people sit.
Oh.
This is the main thing which should be there in the space. This big one, red, is a hydrogen tank. Which will supply fuel to the space shuttle for its fuel, its jet. Space shuttle also has its own 3 jets. These are the supporting booster rockets, white one on this side, one on another side. These are the solid fuel. These are solid rockets. Fuel is solid. In this, fuel is liquid. So first of all, these will create very high amount of boost. And that will take the whole space shuttle quite far. Then these will be thrown out because they are used up. They will come onto the ocean and again reused afterwards in the fuel.
How they will come?
We will see that. And then this is the only red tank left. So these are the booster rockets here also in the jet plane. This
there is connection.
Space shuttle.
In this.
There is a connection. So then this fuel will be used up, and after this is used up, this is also thrown away.
This one?
Yeah, red one, and that burns in the air and then finished. Now this has already reached into the orbit, and it has its own fuel also to some extent to control the navigation, because you cannot use rudder in space because you don't have air there. So there the navigation is done through these. There are on the sides there are small jets of air or such fuel. So by those jets it is navigated. This way if you want to turn, that way if you want to turn.
This is stand project. This is stand.
Yeah, this is all stand. So now you can see.
They included the shuttle itself, also known as the orbiter, plus a pair of solid rocket boosters and a single external fuel tank.
Very far away
The external tank, or ET, is the familiar orange structure that dominates most images of the shuttle at liftoff. At more than 15 stories tall, it is the largest single part of the shuttle stack.
15 mala building jitni ऊंची.
From the foam insulation sprayed on the tank's aluminum structure. The insulation
It is 15-story building tall.
मतलब ये बिल्डिंग से 5 गुना बड़ी.
सूरत के जो बिल्डिंग है.
tank acts as a thermos bottle to keep the
ये
super
तोड़
cold
देगा क्या?
propellants from
तो ब्रो जी
evaporating.
इससे कितना बड़ा ये होगा मशीन.
It also helps prevent ice
मशीन बनाने
from
वाला.
forming on the
ये
tank's
क्या हो रहा है?
exterior
ब्रो जी,
and
what's
promotes
happening?
the right aerodynamic shape. for
They are
launching into
constructing
space.
this.
The main job
This is
of the tank
manufacturing.
is to hold about 535,000 gallons of super cold liquid hydrogen
Like
and
aeroplane
liquid
only.
oxygen.
The aeroplane is standing like this.
535 million gallons of liquid hydrogen and oxygen comes into this tank.
What project? 500 and
35 million gallons.
gallons means
1 gallon is 2 liters.
2 liters.
2 liters or something.
1
I
gallon.
don't remember.
535 gallon millions.
million gallons.
The lower portion of the tank holds the liquid hydrogen, which is the fuel for the engines. The second coldest known chemical. It is stored in the tank at minus 423 degrees Fahrenheit. The upper part of the tank holds liquid oxygen, chilled to minus 297 degrees. During the space shuttle fleet's 30 years of operation, the tank, like the shuttle itself, has undergone numerous upgrades and weight-saving improvements. For example, designers quickly saved 600 pounds by not painting the tank white after the first 2 missions. Following a few revisions to designs and materials, the latest version of the tank, known as the super lightweight tank, is 17,000 pounds lighter than the first one Columbia used in 1981. The tank also received extra attention after 2003's Columbia accident, which
This has all its own jets, and the first when it lifts up is because of this rocket booster, mainly.
was blamed in part on a piece of the
The two are
insulated
there,
foam
no?
on the tank breaking off, striking the left wing,
And both will
creating
use
a hole in the shuttle's heat shield.
together project.
Engineers implemented changes to the foam in the way it is applied and refined before the next launch. Some foam was removed altogether to eliminate risk further. The twin solid rocket boosters, or SRBs, are bolted to either side of the tank. with the shuttle itself riding piggyback.
Okay, what is this?
This
This is all structure to support this.
approach was
It has to
revolutionary in
stay
rocket
straight,
design when it
correct?
debuted in
And they are
1981.
destroyed in once.
Until then,
Rosie?
rockets were built by stacking one stage on the top of another, and then casting off the stages one at a time until a small spacecraft was left on its own in orbit.
What is that, Rosie?
Until the Space Shuttle's first mission in 1981,
Oh,
no astronaut had ridden into orbit on the strength of solid-fueled rockets. The SRBs hold their own fuel, a mixture of powdered aluminum and a chemical called ammonium perchlorate. When dry, the combination feels like a pencil eraser. The fuel is the solid in the solid rocket booster's name. The 15-story tall boosters work much simpler than liquid-fueled rockets that require complex engines and pumps. They produce nearly 7 million pounds of thrust. The solid rocket boosters do not ignite until the shuttle's main engines are up and running. At liftoff, flames shoot down through the inside of the booster to ignite the fuel. Once ignited, the boosters cannot be turned off.
Once ignited, the boosters cannot be turned off.
Means now
Solid rocket boosters, these two, once ignited, once started, it will just finish the whole fuel, then only it will finish. You cannot turn it off.
What?
That's how it is constructed.
Oh.
A pair of boosters combines to burn 9 tons of fuel every second.
It burns 9 tons of fuel every second.
The boosters accelerate the 4.5 million pound shuttle stack to 3,000 miles per hour and 24 miles high in just 2 minutes. By then, most of the fuel is used up and the
Oh,
boosters
see.
So the boosters, when the fuels are used up, SRBs, they are thrown out.
fall away, leaving the shuttle's own main
where they-
engines to reach
So
orbit.
they will fall away. Now they are coming down.
Parachute safely into
Parachutes.
the ocean, where they are recovered.
With parachutes,
reaching
they
some
fall on
bigger
the
launches.
ocean and then they are recovered
After the shuttle
and used
engine is
again.
shut down and the orbiter is on its way, the external tank falls away. And
Now the tank is also used up, so it is thrown away, and the fuel tank just burns up. This red tank just burns up.
safely burns up in the atmosphere over the ocean.
Yeah, boosters
So
are
it is going into water. What is this? Water or clouds?
Water.
Automatically it will open.
Yeah, they have their system. They have their system. It will open automatically. When they,
It is big one, no?
they have their system by which it opens automatically.
There is hydrogen.
NASA's shuttle's fleet
Hydrogen fuel
performed
tank
unprecedented
was thrown out when hydrogen was used.
What will happen to that?
It will just burn and
What?
finish.
Just
it will
tank,
come, it will
tank.
come.
Yeah, tank will burn and finish.
Iron.
work in orbit.
Rosie?
Whether deploying spacecraft to distant worlds, setting up the Hubble Space Telescope to view the edge of the universe, or building the largest orbiting laboratory in history. Getting into space to perform that historic work took teamwork with the machinery of a shuttle stack.
Special launch sequence.
This is another video. It's almost similar,
Space Shuttle was
built Oh.
by 8-year-old Nick Seabold
but
in Tampa,
low
Florida,
quality.
in the USA. Nick really wants to know how the space shuttle
Photos.
managed to get off the ground. Let's head to the launch pad of the Space Shuttle Discovery to start our journey. So just how do you get a 2 million kilogram object to defy gravity and launch into orbit as much as 400 miles off the surface of the Earth? The key to the shuttle's success is the enormous amounts of thrust it can generate. You can see here that the shuttle is mainly made of 3 parts. The shuttle itself, the big orange part called the external fuel tank, and 2 smaller wires either side. These are called solid rocket boosters, or SRBs.
How much far they are standing?
Let's join mission control for launch. And then once you're in the air, I'll tell you a little bit more about how they work. 12, 11, 10, 9, 8, 7, 6. Main engine start. 2, 1. Booster ignition and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond. How fantastic was that? The SRBs are responsible for most of that power, about 71%. The 3 smaller main engines of the shuttle are responsible for the other 29%. The fuel they need to burn is stored in the external fuel tank. This enormous orange tank can store an incredible 719,000 kilograms of
Who
fuel.
are sitting in space.
The fuel itself is a mixture of liquid hydrogen and liquid oxygen, in a very precise ratio of 6 parts hydrogen to 1 part oxygen. This fuel is delivered to the main engines at a rate equivalent to emptying a family-sized swimming pool every 10 seconds. As you can see here, 2 minutes into the flight and 20 miles up into the sky,
Oh,
the
seabed
SRB
12.
separates from the rest of the shuttle and parachute back down to the sea
That parachute.
and reused. 7 minutes later, the external fuel tank leaves the shuttle and burns up in the atmosphere. You can see here a view of the external fuel tank falling, taken by the astronauts aboard the shuttle. The shuttle engines have now cut off, and it is in orbit around the Earth. So after all that effort, why did the shuttle...
Now the shuttle is orbiting.
No?
Yeah, it's out of the atmosphere of Earth and it is orbiting the Earth.
Back and forth to the International Space Station.
And
So
pilots.
now whatever they want to do, they can try to do.
220 miles above the Earth and orbiting
Astronauts are in shuttle.
17,500 miles an hour.
What is that project?
This is telescope.
This is called International Space Station, which is orbiting around the Earth according to them.
You can see here the space shuttle docked to the ISS in order to let the crew members on and off. The shuttle also acts as a platform from which
What is
astronauts
this project?
You're fine.
This stands
People.
for extra-physical activity. It's just a fancy term for a spacewalk. The main reason for spacewalking is to make repairs to the shuttle or the ISS. Most shuttle missions stay in space for between a week and 2 weeks. After this time they return to the Earth. However, like takeoff, this is not a simple process. The angle of the shuttle at re-entry has to be exactly right. If it's even slightly wrong, the shuttle will either skip off the atmosphere like a stone on a pond, or just break up.
This is one thing. When the shuttle has to come down on the Earth, then its entry is very much important, how it enters, because Earth's, just you can hold this, let's expand the bond, otherwise there may be problem. Where is your pen? Where is the pen?
Here.
See, this is part of there, this is the atmosphere of Earth, and shuttle is coming.
This work is done. This is already finished and now it is
Their work is finished.
So, it's small also. Is coming. Now it has to be at exactly proper angle, because if it is not at proper angle, what happens? Here there is no air, it's just vacuum, and here is immediately the air starts. So it will just bounce like this. For example, in a river or in a pond, you have this stone.
Yes.
So like this, what happens? It bounces 1, 2, 3, 4. Right? So if the angle is not proper, space shuttle will bounce like this. As soon as it bounces, misses to enter. It will miss to enter. It will bounce and go. And again they have to go around and come back.
No, they cannot come from there.
No.
Any side.
From wherever it bounces like this, then it has to again enter. We have to make efforts. And it will also damage the airplane. So that's why that angle is very important. So they control the space shuttle to enter at a particular angle. So when it enters, now there you are able to see the bottom part of the shuttle is very flat and black.
Yes.
Able to see?
Yes.
Specifically made, this is bottom part of the shuttle.
Last.
Bottom. So it goes like this. Bottom part, niche ka part.
Huh.
So it it is specifically made like that to re-enter into atmosphere. When it enters here into atmosphere, what happens? It immediately comes with high speed in contact of air. So very high amount of heat is generated because of the contact with air, with high speed air. You have contact with, so that's a very high amount of heat, very bright fire will be generated. So this is a special design material down which is able to withstand the heat. And then gradually it is navigated back to Earth by the wings and radar.
How it goes by the wings, Guruji?
Same principle as plane.
Like we fly our paper airplane. Huh?
The correct angle is reached using a vector. This is where the shuttle rolls over 180 degrees. Once this is done, the shuttle still has to negotiate its way through the atmosphere. As it hits the air, travelling at 17,000 miles an hour, it's an incredible amount of friction. You can see how much heat is generated by friction. All hands together.
Oh, this is heat.
It has a speed of, when it enters, it has a speed of 17,000 miles an hour. That is about 24,000 or 17, half of 17 is 9, 26,000 kilometers an hour. So how much heat will be generated, you can understand.
These speeds. Here you can see an artist's impression of the glowing underbelly of the re-entering shuttle. As if that
Now it's
wasn't hard
coming down.
enough, the shuttle still had to land safely.
At land,
Aerodynamically designed to glide down to the runway. It
like
has
aeroplane.
no
like
power.
aeroplane. Paper
The
airplane.
onboard computer makes a series of S-shaped turns to slow down the shuttle as it approaches the runway. When there's only 25 miles to go, the shuttle commander takes over and steers the shuttle home. This fantastic feat of human engineering has been taxiing back between Earth and space since 1981. The shuttle will retire in 2010.
There are
after
wheels also
29
in shuttle.
years of service. Let's hope it's
How it will
replaced
otherwise
by rides
fly
that
and
capture the
navigate.
imagination in the same way.
If there are no wings, it will fall like a
So
stone.
until next time, remember,
Correct?
science is fun.
Exactly like aeroplane.
Let's see.
Firm.
But this the astronaut should be very trained.
Yeah.
Very much.
Everyone must be very trained. One who makes it must be very trained.
And
So they
even
do waste their time in all these things. So much time it takes to do all these things. Right? It's not a joke. To make these things work. It requires so much time and energy of so many people. And what is the result? You get satisfaction that we were in space.
The White Brothers are not. White Brothers.
Right, brothers?
They are not.
Right, brother.
Right.
They are not.
They are not. Yet it's not in this.
They only died.
They made antenna.
Yeah, that was very.
17 something.
What 17?
17 or 18, yes. Yes.
19.
No. When? Not 19.
I don't know the year. I'm very
So
poor in
there was no
remembering
concept
the
about
years.
No, 18. Do something 18 type.
So,
I can stop. Sunita Williams.
Sunita Williams.
I don't know.
That was
Now recent news is there. Sunita Williams went to this Mars. That means orbiting Mars.
This is all. See, all these things I don't believe. They are all.
Sunita Williams died. In
No.
my textbook only they said that Kalpana and both died.
Both were.
was the first.
Yes.
Kalpana was the first, the next Sunita Williams died.
No, I heard that she is orbiting Mars. Means,
Maybe she went to Mars.
It's
No, but Mars is a Swargaloka. How can she go to Mars?
2012
He's
2013
gone.
he died.
Even go to moon.
2012
Most also can go to
2013,
Mars.
like this.
Died.
No, she was orbiting Mars, Mangalyaan.
She may be orbiting Mangalyaan, which is there on the earth.
Recently, only, but because before she died, she went to Mars like this.
She did not go to Mars.
Mm-hmm.
You have been
It
cheated.
was on 30 to
Means-
49 nights.
Recently?
Without textbooks, it
I don't know.
that-
I don't
Which
think so.
11 died? 2002.
Anyway, so many people die.
They were also.
Rakesh Sharma.
Everyone will die.
So the point is that these technology, you can see how much complicated it must be. Correct? To get everything right, it is very, very complicated to get everything right. So it takes a lot of time and energy of human life. Now you can understand why everyone is working so hard. Because you require contribution from everyone to maintain all these things. It's not so easy. So that's why Srila Prabhupada says in Hare Krishna Challenge book that you may have got some benefit by bringing electric lights from first you had castor oil lamps, now you have electric light lamps. So you may have got some benefit, but at what cost? At the cost of the time, invaluable time of the human form of life. You are just wasting in these things.
That time also they lived. This time also they lived.
What happens? What's the result? That's the point. You are just working like, oh, I did so many new things. But what's the result? Result is not happiness. Previously also you are dying, now also you are dying. Previously also everyone was becoming old, now also you are becoming old. So what benefit you have got by doing all these things? That was the point of it. So because these things are very complicated, it takes so much of our time when we entangle into modern civilization. Because we have to pay for these things. When we are using, we have to pay for this. Otherwise how the things will go on? For that we have to work. This is the whole point. This complex modern system requires so much of energy into it. And thus our whole attention goes into that, and the real job of human form of life is forgotten. That is the problem. These are all very complicated things. To get it done, really, it is very complicated. Maybe to understand in principle, it may be little easier. To get it done, everything is very complicated. If the plane is flying and both the wings are not exactly the same, there is some difference. Either in design, even if the design is same, but on one wing some more dirt has come. Yeah. And on another wing it is not there, less dirt is there. Then also there will be imbalance. Because less lift will be generated here, more lift will be generated there. So there will be imbalance. So you have to balance it now. Anything can cause crash. Correct? Both engines, exactly same amount of power should be there. Rudder should work exactly properly. It should be exactly similar. What do you say? Symmetric. Otherwise, it will constantly create some draft on one side, turn plane on one side. So many such things are there.
But aeroplane cannot turn like this fully. Little he's turning.
It's not cannot. It can just go like this and crash. You have to control it so that it does not. You understand? If there is some error, immediately it will crash. You have to control it in a way that it doesn't crash. For that you require a lot of energy, lot of intelligence put into, and not just intelligence, even if it is designed properly, you have to constantly put your efforts to keep it running properly.
Awareness.
It's no joke. So you require a lot of energy, lot of people have to work for that.
And they're taking this in free. ICT. Whole money. They're taking in free.
No, you are using these technologies, you are using these things, so you have to pay for it, isn't it? That's why people have to work so hard.
1,000 for each person.
You have to work so hard. If you are using this technology, then you have to pay for it, and for paying for that, you have to work hard. So the whole aim of human life is lost. That's what is happening.
They are just doing this with so much effort, but before in ancient times people also used to go, even in ordinary they used to go up and down.
That's altogether another thing. That's a different technology.
They are using
That is,
mantra.
yeah. These are all based on Shastras. So they used to have the same purpose fulfilled.
But
Without
Without complications.
without any
No,
effort.
they used to have their efforts in
but much
making the mantra siddha, so that they get that power to use that mantra.
but after becoming Siddha.
But there is one I heard, Akash Shanam. On whatever asana you sit, with that asana you can fly.
Yeah, but that asana will fly. Why it will fly? Because someone has done that austerity and made the mantra siddha, so that by that mantra the asana is flying, so that anyone who sits on that will fly. It's like that. It's the same thing. Someone has made aeroplane so that anyone sits in the aeroplane can fly.
But aeroplane is so much.
Every time we have
That
to
type
do,
of effort already is done by some muni for making that asana, so that the asana could fly. Correct?
but Roji, aeroplane have to.
Aladdin.
It doesn't
Aladdin also did that.
sucks effort of others, but he
Is it real?
individually.
Yeah, now that is a different thing. That individual is doing austerity, so others are supporting him. So in that way, but it's the method which Lord Shri Krishna has given. It's not our own method which we have made. So that effort is not against Krishna consciousness. It is based on mantras, subtle science.
Prabhupada writes in Ishopanishad, 3 by 3 ways we can go.
Akasha Patol. Kapota, Kapota, Akash Patol.
By worshipping demigod,
Oh, this is a different. On other planets, how you can go to other planets?
by worshipping demigod, by Yog Siddhi, and by spaceship.
We can go where?
Yeah, I don't know which spaceship, but Prabhupada
Yeah,
writes.
that's a different spaceship, not this spaceship.
Roji, what is the meaning of spaceship?
In Vedas,
Ship which floats in space.
Robot spinning of shuttle.
Shuttle. Shuttle. I don't know exactly the literal meaning of shuttle.
Because in badminton, shuttlecock is there. That
Shuttle-
is also flying in
shuttle
air.
auto.
That also
Like
floats.
Shuttle auto.
That also floats in air like this.
Shuttle.
And that shuttle is also.
But then why airplane is not called shuttle?
Because it is not. We have to control that. But that shuttle is after going
also
to
we have to
after.
control.
Huh?
Space shuttle also we have to control.
Yeah.
But it is floating.
No.
We
have to control.
We have to
There must be some
control
reason.
that aeroplane.
There must be some reason, we don't know. Simple. So okay, this was about space shuttle.